Hey there. I will always remember this time when we were interviewing a programmer for our software team. His resume wasn't particularly interesting, but then we got to the coding challenge, and in the coding challenge we asked him to write a function that would give us the nth number of a Fibonacci sequence. And in just a few minutes he was able to do just that. My supervisor later asked me what I thought about him, and I gave a good review, and then we hired him onto our team. So coding challenges are really crucial for job interviews. It helps employers see who actually knows how to code. It's easy to write in your resume your coding experiences and your coding projects, but a coding challenge really helps the employer see how you would think through your code and actually see how you might code in action. So in this video, we'll be talking about the Fibonacci sequence, and I'll go through this challenge myself and show you how I would go and approach this coding challenge. Alright, let's get started. My name is Henrik, and I'm here to teach you how to program your own applications, stress less, build more, save time, and improve lives. Before we begin, if you're just learning how to code or you want a project that helps you get better at coding, I have a free guide called my Personalized Finance App Programming Guide. It's a free guide that teaches you how to go from no coding experience to building your first app. And in this app, you will take your credit card transactions and then categorize them into different budget categories so you know how much you're spending. And it's a free guide. It goes step by step how I would go and approach this project. And you can download it in the link in the description. And if you download it and pay attention to what it says, you'll definitely learn some fundamental programming concepts. Alright, so here's a website from Geek for Geeks. I will put the link in the description. But basically, first they talk about Fibonacci numbers. So if you're not familiar with a Fibonacci number or a Fibonacci sequence, basically it's a sequence that starts from 0 and 1, and then you just add these two numbers to get the next number, and then you add these two numbers to get the next number, and then you add these two numbers to get the next number, and so on. So in mathematical terms, it looks like this. Basically, Fn is the nth number on this sequence. So F0 is 0, F1 is 1, and then F2, which is this number, is going to be the sum of 2 minus 1, which is F1, and then 2 minus 2, which is F0. So F1 plus F0 is going to equal F2. And F0 and F1 are just 0 and 1, so then F2 is 1, and that's what we see here. Make sense? Alright, so here's the full coding challenge that we gave to the interviewee. Given a number n, print the nth Fibonacci number. So for example, like what I just mentioned, n equals to 2, the output should be 1. So if n equals to 9, that means F9 is equal to F8 plus F7. So what is F7 and F8? This is F0, this is F1, this is F2, F3, F4, F5, F6, F7, and F8. So F7 is 13, F8 is 21, 21 plus 13 is 34. So F9 would be 34. So if n equals 9, the output should be 34, and that's what we see here. So we have to write a function int fib with the input n that returns fn. So for example, if n equals 0, then fib should return 0. If n equals 1, then it should return 1, and etc. Okay, so let's do this. So I'm going to do this in Visual Studio Code. I have a folder called Fibonacci, and I'm going to create a file, and we'll just call it Fibonacci.c. Alright, now we're going to code this in C. You can code it in whatever language you like, but I'm more comfortable in C. Okay, let's just run this basic program and see what happens. Okay, there you go. So now we need to write a function. So the function will do int, we'll use the same exact ones that they used in the prompt. So it should be this exact. Okay, so I just created a function that will print I am in fib and then return 0, because the return value of this function is an int, so we should return an int. So let's run this. Okay. All right. Now let's make a variable called int return value, and we'll set it equal to 0. We'll initialize it to 0. And then return value will get the value of the function, or the return value of the function. So fib 0. And then we will print the value that we got from the return. Okay, so we're just going to put the value here and return what the number is. Oh, if you get this error, it means you have to declare the function. So we have to declare the function up here. We're just telling the compiler that we have a function with this return value and this argument. Okay. All right. So I am in fib. It means I was able to run the function, and the function is gonna print that string, and then it returns 0. So if I put in 5, and then we run this, and then you get the number is 5. So we already know from the problem itself that if n is equal to 0, then we should return 0, and if n equals 1, then it should return 1. So let's just put that in right now. If n is equal to 0, return 0. And then same for 1. Okay, now let's run this. We should get 0. Okay, good. The number is 0. Now if you put in 1 here, the number is 1. All right. Now during that interview, we only asked the interviewee to just write this function for us. We didn't really have them write out this whole thing, but I'm just writing it like that so that we have an actual functioning program. All right, so we already have the cases for 0 and 1. Now let's say if n is greater than 1. Like in here, it says if for n greater than 1, it should return fn minus 1 plus fn minus 2. This part will handle the n greater than 1 case. So if n is greater than 1, it'll come through in this code block. So at this point, I would be thinking, how do we need to get fn minus 1 and fn minus 2. So how do we get that? How do we get those two numbers? Say for example, let's pretend n was 4. So we need to get f3, 3, and f2. So what I'm thinking is maybe we use a while loop, because if we want to get f4 is just going to be f3 plus f2. So at the end of the loop we'll get f4, but then the previous iteration I want to get f3 is equals to f2 plus f1, and then the iteration before that you want f2 is equal to f1 plus f0. So I'm thinking to do a while loop that will do this calculation, then this calculation, then this calculation, something like that. So let's do a while loop. Let's just say while true. So when you're doing your interview, it would be good for you to say what I'm saying here. Like I'm thinking out loud how I would go about doing this, and then it's good for the employer to know how you're thinking about doing this as well. And that's what the purpose of the coding challenge is, right? So make sure that you voice what you're thinking as you're writing your code. Okay, so I want this while loop to go through this. I want to go through 3 iterations, 1, 2, 3 to get f4. So actually, yeah, so pretend the n is 4. We should also bear in mind that we can also hit the 2 case. So we can also pretend n is 2, and if n is 2, we only need to do that calculation. So basically we only want to run the while loop once. So the way I would start is I'll do seed 0 is equal to 0. I'll start with the f0, because as long as n is greater than 1, you're going to have f1 and f0. So you already know you always have these two numbers, f1, f0, when in the n greater than 1 case. All right, so I'm going to create a number called the nth number. this is the one that we're actually going to return. I'm just going to initialize it to 0. And we want something like this. So after the first iteration, we'll get f2. But then, for the next iteration, we want nth number is equals to, this is now f2 plus, so this is for the f2 case. Now for the f3 case, we want nth number, which was f2, and f1, which is gonna be seed 1. And then for the f4 case, we want f2. So this while loop should have memory of the last two values. That's something that I know for sure, because you need seed 0 and seed 1, and you need to remember the previous number and the number before that, etc. You need to know this number and the number before that. So how do we preserve those two numbers every iteration of this while loop? So now that we have that idea, I think we should store an array. We should create an array. Now that I'm thinking that we need to have memory of the previous two values, I think we need to create an array. So let's create an array, int the last two, like this. Okay, so we know the first one's gonna be 0, the second one's gonna be 1. Then we need to replace these numbers for the next iteration. So if we just remove seed 0 and seed 1, we can just use last two 0 and then last two 1. So that will give us 0 and 1, right? And then so 0 and 1 for f2. And now for the next iteration, we want, after we do this calculation, we should replace those last two numbers, right? We should do last two 0. It's going to be last two 1, because 0 is going to be 0, last two 1 is going to be 1. And then we want last 0 to be 1, and then we want last two 1 to be nth number, because we're going to replace this number with the previous, the number that was just calculated, and then we're going to use this nth number for the next iteration. So for the f3 case, we're going to use the number that was calculated for f2, and then we're also going to use f1. So this one replaces f0 with f1, and then this one replaces f1 with f2. And that's how we can get f1 and f2 for the next iteration. When f3 comes along, we can just use the same exact formula, and that's what we want. I think we should keep track of the iterations, right? And this value is going to be n-1, because pretend it's 4, right? Then we only do 1, 2, 3 calculations. If it's 2, we do 2 minus 1, which is just 1 calculation. So number of iterations, we'll set it to 0, because we're in the 0th iteration. We haven't done any iterations yet, so we set it to 0. And then we want to get out of the while loop when num iteration is equals to n-1. All right, so we'll break out of the while loop after the third iteration. If the n is 4, we'll break out of the while loop after the third iteration, 1, 2, 3, and we need to increment the num iterations. All right, we need to change this condition, because it would only go in the while loop if this condition is true. So if num iteration starts off as 0, and then this one will become n-1 is going to be 3 minus 1, which is 2. And then so in the 0, it will be 0 is less than 2, so it's going to go in here. And then it become 1. then 1 is less than 2, and then it'll execute again. But then num iteration is going to be 2. 2 is not less than 2, so it's going to exit. So if num is equal to 3, it will execute this while loop twice, which is what we want. And then we exit the while loop at the right time, and then we want to return nth number. Alright, so this might magically just work. Something that we can do here is we can put a print statement so we know exactly what we're adding. Okay, let's run this. We should see the print statement for that calculation. Alright, so 0 plus 1 is 1. Let's see if we get 8 for the n is equal to 6 case. Okay, so it's working. So we did it. So this is just one way you can do it. There's a lot of other ways you can do this. When I first thought about this, I actually wanted to use recursion because we're adding f1 and f0. So when I saw that, I was already thinking of recursion because we already have this imaginary fib n, which is supposed to return the nth sequence. So we could just we already have the cases for 0 and 1. So what I was thinking was we could just return fib n 0 plus fib 1. So this is always going to return the 2 case. So if we run this one, fib 0 and fib 1 is just going to return 0 plus 1. So the number is 1. And I am in fib means we went in here once, but then because we called we did a recursion, we called the function again inside the same function. So fib 0 went in here and gave us 0, and then we ran this function, and then fib 1 came in here and said I am in fib. That's why we have 3 I am in fib strings. So the number is 1. Now if n is equal to 2, so remember this block, anything that comes after this, n is greater than 1. So we could actually just say n minus 2 to get 0, and then n minus 1. So we get the 2 previous values, say pretend that n is equal to 2. Then we want fib 0, right? Just like what we just showed you. We want fib 0 and fib 1. But if n is equal to 2, then this is just 2 minus 2, and then this is just 2 minus 1. So that's why I replaced, so I'm just replacing the n here. I'm just replacing the 2 with n. And then we can just run this, and then we get num is equal to 8. Number is 8. Now what is our 6? 6 was the number. So does that make sense? Okay, 0, 1, 2, 3, 4, 5, 6. 6 is 8. Okay. So it did give us the right number. So maybe we try 9, because that's what that's one of the examples that we saw. N is equal to 9, so we should get 34. So let's try that. So it's iterating a lot. It's recursively executing the same function over and over again. So the number is 4. And then so we don't see the annoying I am in fib message, you can just run this once. There you go. The number is 34. So those are the 2 ways you can write this Fibonacci function. And I like this way because it's a lot simpler. And I was already naturally thinking I just wanna run the same function again instead of doing all this remembering of the last 2. So there's a lot more lines here. But actually this one is more efficient, I think, because you only run this amount of code. But as we saw earlier, when you use 9, you're running the same function many times. So I think this one is better in terms of calculations, but this one is better to make your code look nicer. You only have those 2 cases, and then you just return the previous the previous two summed up together. But just for fun, I want to comment this out and see if we still get 34. Yeah, so we still get 34. Nice. So those are the two ways you can do this. And when you're in your interview, they might ask you to do either one. So if you code it in the recursion way, they might ask you, oh, can you do it without using recursion? And then you have to do this way. But if you do it this way first, they might ask you, can you do it with recursion? And then you have to do this way. So now that you've watched this video, you know how to code both ways. Alright, so I hope this was helpful for you. And if you have any questions, feel free to leave it in the comment section. I'll be answering the questions there. I know this was more difficult. This was a medium level difficulty. So I understand that it can be confusing. So feel free to leave a comment. And if you haven't downloaded it yet, I have that free guide called my personalized finance app programming guide. It teaches you kind of like what we did today in this video. It teaches you how I would think about going about this project. And I think projects really help you get better at programming. When you learn one way of doing things, you have another way in your mind of how you would go about doing something else. Alright, thanks for watching. Thanks for making it to the end of this video. I hope this was helpful for you, and I'll see you on the next one. Peace.